Machine learning is a fascinating field that allows computers to learn without explicit programming. Think of it like this. Instead of giving a computer step-by-step instructions, we feed it lots of data and let it figure out the patterns and rules on its own. This ability to learn from data makes machine learning incredibly powerful and adaptable. It's like teaching a child to ride a bike. You can't explain every little detail, but through trial and error they eventually learn. Machine learning is used everywhere in our daily lives. It powers recommendation systems, like those used by Netflix and Amazon, to suggest movies and products we might enjoy. It helps filter spam emails and detect fraudulent transactions, keeping our inboxes clean and our finances secure. Even voice assistants like Siri and Alexa rely on machine learning to understand and respond to our requests. The key to machine learning lies in algorithms. These algorithms are like recipes or sets of instructions that guide the learning process. They analyze the data, identify patterns, and use those patterns to make predictions or decisions. Just like a chef uses a recipe to bake a cake, machine learning algorithms use data to bake intelligent systems. As machine learning continues to evolve, it promises to revolutionize countless industries and aspects of our lives. From self-driving cars to personalized medicine, the possibilities are truly limitless. Imagine you're teaching a dog a new trick. You don't simply tell the dog what to do, you show it through repetition and rewards. Machine learning algorithms learn in a similar way. They are fed massive amounts of data which act as their training material. This data can be anything: images, text, numbers, depending on the task at hand. The algorithm then analyzes this data, looking for patterns and relationships. For example, if we're teaching a machine to recognize cats in pictures, we would show it thousands of images labeled as cat or not cat. The algorithm would then identify features that are common to cat images, such as pointy ears, whiskers, and a tail. As the algorithm processes more data, it refines its understanding of these patterns. It's like practicing a musical instrument. The more you play, the better you become. This process of learning from data is called training. During training, the algorithm adjusts its internal parameters to improve its accuracy in recognizing patterns and making predictions. Once the algorithm is trained, we can test its knowledge on new, unseen data. This is like giving the dog a command it hasn't heard before and seeing if it responds correctly. The algorithm's performance on this new data tells us how well it has learned and how well it can generalize its knowledge to different situations. Machine learning algorithms come in different flavors, each suited for a specific type of task. One way to classify them is based on the type of supervision they require during training. Supervised learning. This is like learning with a teacher. The algorithm is given labeled data, meaning each data point is tagged with the correct answer. For example, in our cat recognition task, each image would be labeled as cat or not cat. The algorithm's job is to learn the relationship between the images and their labels so that it can correctly classify new, unseen images. Unsupervised learning. This is like learning without a teacher. The algorithm is given unlabeled data and must discover the underlying structure or patterns on its own. For example, an unsupervised learning algorithm could be used to group customers with similar purchasing habits or to identify anomalies in financial transactions. Reinforcement learning. This is like learning through trial and error. The algorithm interacts with an environment and learns by receiving rewards or penalties for its actions. For example, a reinforcement learning algorithm could be used to train a robot to navigate a maze or to play a game. Each type of machine learning algorithm has its strengths and weaknesses, and the choice of which one to use depends on the specific problem at hand. Understanding a few key technical aspects can deepen your appreciation for the intricacies of machine learning. Overfitting. Imagine a student who memorizes the entire textbook but struggles to answer questions that are phrased differently. This is similar to overfitting in machine learning. It occurs when the algorithm learns the training data too well, including its noise and outliers. As a result, it performs poorly on new data because it has not learned the underlying patterns, but rather memorized the specific examples it was trained on. Generalization. The goal of machine learning is to create models that can generalize well to new, unseen data. A well-generalized model can accurately predict or classify data it has never encountered before. Training data. The quality and quantity of training data are crucial for the success of any machine learning model. If the training data is biased, incomplete, or noisy, the model will likely perform poorly, even if the algorithm is sound. These technical aspects highlight the importance of careful data preparation, model selection, and evaluation in machine learning.